at wavelength that forming galaxies in the beginning of the universe. James Webb Space Telescope is upsetting the apple cart. For decades, black holes have remained one of the most mysterious and awe-inspiring entities in the cosmos. They are defined by their insatiable hunger, their infinite gravity, and their one-way boundaries. The event horizons beyond which nothing, not even light, is thought to escape. Yet, in a groundbreaking and mind-bending observation, NASA's James Webb Space Telescope has captured something extraordinary. A stream of material, energy, or light apparently coming out of a black hole. This single event has sent ripples through the astrophysics community. Not only because of what was seen, but because it seems to challenge the foundational assumptions about what black holes are and how they behave. Before we start, smash the like and subscribe buttons for more updates. The observation took place in a relatively distant galaxy where a supermassive black hole resides at the center. While black holes are often surrounded by chaotic environments, accretion disks of gas and dust spiraling inward at near-light speeds. What the James Webb Space Telescope recorded defies expectations. It captured what appeared to be a highly columnated jet, a structure often theorized in conjunction with black hole activity. But this one was different. It wasn't just the standard relativistic jet pouring out from the poles of the black hole. The kind of energy ejection that's long been observed and attributed to magnetic field lines outside the event horizon. This was something deeper, stranger. The jet appeared to be emanating from closer to or even from within the event horizon itself, a notion previously thought impossible. The light spectrum picked up by Webb was unusually rich and consistent with a previously unobserved high-energy phenomenon. Scientists noticed radiation signatures that indicated interactions between extreme gravitational forces and unknown forms of matter. There was synretron radiation typically associated with particles accelerated to near-light speed. But the intensity and coherence of the emission implied an origin far deeper in the gravitational well than any current model could explain. The fact that this data came from the James Webb Space Telescope gave it additional weight. With its unparalleled infrared sensitivity, Webb can peer through dust and gas clouds that typically obscure galactic cores. The clarity of the data was both astonishing and unsettling. What came into view wasn't a simple burst or flare, which can be relatively common in active galactic nuclei, but a sustained directed ejection resembling a fine beam of structured energy. It had a periodic component, suggesting that it might be modulated by some internal process, perhaps tied to the spin or magnetic alignment of the black hole itself. The idea that material could escape from inside the event horizon contradicts our current understanding of general relativity. According to Einstein's equations, nothing that crosses the event horizon should ever return. And yet, this observation hints that either our understanding is incomplete or some unknown mechanism is at play, one that permits energy or information to re-emerge. One possible explanation, albeit speculative, is that quantum effects near the event horizon could be allowing some form of Hawking radiation to be structured and amplified. Traditional Hawking radiation is incredibly faint and chaotic, the product of virtual particles flickering in and out of existence at the boundary of a black hole. But what if under certain extreme conditions, these quantum fluctuations could organize into coherent streams of energy? Perhaps the intense magnetic fields and rotational energy of the black hole act as a catalyst, aligning and accelerating these quantum emissions into jets observable by instruments like Webb. If true, this would mean black holes are not entirely sealed off from the universe, that they have subtle but powerful ways of communicating with the cosmos beyond their borders. Alternatively, this event could suggest the presence of an exotic form of matter, something that behaves differently under extreme gravity. Theoretical physicists have proposed entities such as axions or other weakly interacting particles that could escape from high-gravity regions, even from just inside the event horizon. Under specific circumstances, if the beam captured by Webb consists of such particles, this could mark the first direct evidence of dark matter-like substances being expelled by a black hole. Such an occurrence would revolutionize both astrophysics and particle physics, opening a new era of exploration into the building blocks of the universe. The jet structure also raises tantalizing questions about black hole interiors. Traditionally, what's inside the event horizon is considered unknowable. It's the realm of singularities where space and time collapse into an infinitely dense point. But the periodic and modulated nature of this beam suggests that some form of organized motion persists even within the gravitational abyss. Could it be that black holes don't collapse into singularities in the traditional sense, but instead stabilize into some unknown state of ultra-dense matter or energy? Perhaps what we are seeing is an echo of internal processes, not light in the conventional sense, but information being carried out via an as yet undiscovered channel. Some have speculated that wormholes, hypothetical tunnels through space-time, might offer another explanation. If a black hole were connected to another point in space-time via a wormhole, it's conceivable that material or radiation could emerge on our side from the far end of that connection. The consistency and sustained nature of the beam could align with this possibility, though wormholes remain deeply theoretical and controversial. Still, the James Webb image provides tantalizing observational clues that could energize this line of research, shifting it from abstract theory into something potentially testable. Moreover, the orientation of the jet with respect to the black hole spin axis has given astronomers further puzzles to contemplate. In most black hole systems, jets align with the rotational poles shaped by magnetic field lines threading through the surrounding accretion disk. However, this new emission doesn't quite follow that rule. It emerges at a slight offset, a deviation that may imply complex inner dynamics or multidimensional structures at play. Perhaps the very geometry of space near the event horizon is warped in ways we've yet to understand, creating channels through which energy can escape in unexpected directions. The broader implications of this finding are profound. If black holes are not the one-way prisons we've always imagined, then the nature of information loss in the universe must be re-evaluated. One of the deepest problems in physics, the black hole information paradox, centers on whether information that falls into a black hole is truly lost forever. This event might be the first observational clue that information in some transformed and extreme format does eventually find its way out. It challenges the classical definition of a black hole and blurs the line between event horizon and external reality. There's also a more cosmic angle to consider. Black holes are not just endpoints of stellar evolution or galactic anchors. They are active participants in the shaping of galaxies, influencing star formation, regulating gas flows, and possibly even seeding the conditions necessary for life by triggering massive cosmic events. If black holes can eject not only energy, but structured information or exotic particles, they may serve as nodes of transformation in the cosmic web. Not just destroyers, but creators and conveyors. The timing of this discovery is particularly poignant. Humanity has just begun to unlock the full potential of the James Webb Space Telescope. And already it has delivered a discovery that pushes the boundaries of modern science. It's as if the universe is offering us a challenge to let go of outdated paradigms and embrace a more nuanced, layered, and strange reality. The image of that jet, slender and ghost-like, arching away from the black hole's heart, is more than just a marvel of astronomy. It's a symbol of scientific awakening, a visual metaphor for progress piercing through ignorance. The precision of Webb's instrumentation allowed research